So based on molecular forces. So if I ask you to name some of the intermolecular forces, so these forces could be van der Waals forces, they could be hydrogen bonds, they could be ionic dipole interaction. So based on the types of forces they have, or the smaller units have in them, these kinds of forces also makes us let have this. Over here we see mainly 4 types of, they are elastomers, fibers, thermoplastics, and the 4th type is thermoplastics. So these are the types of different plastics. Some of them have hydrogen bonds, some of them have weak van der Waals. So let's see how are they classified. So the first section is about okay. So as the name suggests us, these substances, they are elastic in, okay. So the best examples are rubbers. So if I have to explain them, the polymers in which the intramolecular forces of attraction between the polymer chain are weakest. So I will say weak forces of attraction between the chains. Okay, so suppose I consider one chain like this, one more chain like this, one more chain like this. Now these chains are linked with each other using some kind of weak forces. Mainly we see that these forces are van der Waals forces. Now as these forces are weak, these polymers are okay. So we see one thing in them. The van der Waals forces allows the substance to stretch up to, they stretch up to about 10 times of their length. Okay. Now if we see their structure, we see that they actually have a very they have a coiled chains linked to each other. So if I draw them, what happens is that they have a chain like this. suppose they have something like this, then one more bend or a coil, one more coil like this, one more coil like this, one more like this, one more like this, and these are okay. But when you expand it, when you have some force on them, what happens is that when you apply some force on them, all these chains try to move apart, and in the end you get a long chains like this. So I can simply say that all the coils open up. Okay, so the van der Waals forces allow the substance to expand or stretch up to about 10 times of their length, whereas when you expand it, if you just remove the force, what happens is that all these links try to make the substance come back to its, so the substance comes back to the original length when the forces removed. So you can expand it, then back to its length, then again expand it, again back to its length. So under this section, the example was rubbers. Okay, now comes the second type, the fibers. The fibers are used to make bags, shirt, pants, suit. Second type, fibers. So in the case of fibers, what happens is that the intermolecular forces are very, very strong. So the forces of attraction are strongest. Forces of attraction are strongest. They have either hydrogen bonding or interaction by dipole. These have very strong bonds, so hence they have very high strength, high tensile strength. But as they have higher strength, they are least elastic. Example. The example under this section comes as nylon and okay, the fibers are also over. The third type is the thermoplastics. Third section, thermoplastics. So I will start this section by an example. So we know that most of our toys are made from some kind of so all your toys, your spoon, plates, everything are formed by them. So what happens is that these substances are hard at room temperature, but when you heat it, what happens is that these substances have very low melting point. So when you heat it, you are able to melt them, and you can mold them. You can mold them into various shapes. So suppose if you have a toy or a spoon, suppose you have a spoon. So for the formation of a spoon, you need a mold of the shape like this, and then in this mold you have to pour hot melted okay. Now what happens is that this process is reversible. So suppose after this you have a spoon like this. Now if you again heat the spoon, you will again get the same hot melted liquid, and now you can pour this liquid from the spoon to make a bowl like this. So you can again and again use the same substance to form one shape, then another shape. They are used for making of toys, telephones, and all the other things. And the best examples are PVC, Teflon, nylon 66, and the other types. Fourth part, thermo setting plastics. What are they? So in the last case, what you see that you can reuse the same plastic again and again. You heat it, then heat and cold, then again heat it, heat and cold, again and again. But over here in these types of plastics, what happens is that when you heat them, you change their actual formation. So the extensive cross linking is formed, cross linking between the chains, between different chains are formed on heating giving a new structure. So example, how to explain this part. So suppose initially you had the formation like this, one chain, one more chain, one more chain, one more chain, like this. Now suppose I have to heat it. I heated it. So on the first time of heating, what happens is that these different chains, they interact with each other and they try to form more and more like this bonds. So after the first heating only, you get a completely new formation. So you have changed. So on heating, you just change the properties of the older plastic. So in short, I can say that These are non-reusable, undergo a permanent change in the composition, and then they form a hard substance. Examples are urea, formaldehyde, polymer. And second example is BACKELITE. For your knowledge, this bakelite is used to make torches and sockets. So as you can see over here, that if you heat your sockets, it won't melt. Why? Because they undergo an extensive cross-linking between the chains on the first time of heating itself.
Thank you for watching. Visit us at needbook.in.